Hey everyone, welcome back. Ready for another deep dive?
Always.
Awesome. So today we're tackling machine learning best practices.
Sounds good to me.
Yeah, and we've got a great source for this, an article from DataPro News. It's called Machine Learning Best Practices. And you know what's cool?
What's that?
It's all based on advice from Andrew Ng.
Yeah.
The Andrew
Oh,
Ng.
yeah, of course. I mean,
Yeah,
a legend in the field.
exactly. So if you're working with ML, or even if you just want to get a better handle on it, this deep dive's for you, like a cheat sheet for all things ML, kinda.
I like that. A cheat sheet.
So one of the things we'll be talking about is this whole idea of rapid iteration in machine learning. Eng has this really interesting analogy about it.
Oh, tell me about it.
He compares it to, like, trying to sell a house before you've even built it.
I see where he's going with that.
Yeah, instead of aiming for this perfect ML model right out the gate, you focus on making progress step by step, testing and refining as you go.
It makes sense. Machine learning is all about that iterative process, right?
Yeah, totally. And we're also going to dig into why choosing the right evaluation metric is so crucial. It's like having a scorecard for your model helps you track how well it's performing.
Couldn't agree more. Without clear metrics, it's tough to know if you're making progress.
Okay, so before we get into the nitty-gritty, let's talk about Andrew Ng for a sec. I know he's a big name in AI, but fill us in a little. Who is he, and why should we care what he has to say?
Oh man, where do I even start? Andrew N., he's like a rock star in the AI world. Stanford professor, founder of Coursera, head honcho at deeplearning.ai. He's really made a huge impact on making AI education accessible.
Wow, impressive.
Yeah, and his research contributions are, like, incredible. You've probably heard of LDA, right? Latent Dirichlet Allocation.
Maybe. Refresh my memory.
So LDA is this really cool way for computers to analyze a bunch of documents, like news articles or whatever, and figure out what the main topics are. It's pretty amazing. And then there's spectral clustering. Ever heard of that one? It's all about grouping data points based on how similar they are. Like, imagine you have a ton of data points scattered all over, and spectral clustering helps you find those natural groupings within all that chaos.
Okay, starting to come back to me now.
Yeah, so Eng has done groundbreaking work in all sorts of areas.
Really fascinating stuff. And for this deep dive, we're looking at insights from his book, Machine Learning Yearning. I've heard it's like a must-read for anyone working with ML.
It really is. What I love about it is that it's super practical. It's not just about the theory, it's about actually building and using ML systems effectively in the real world.
Right, getting down to the nuts and bolts.
Exactly.
So let's get to the heart of it, shall we?
Let's do it.
Okay, so the article we're using pulls out 5 key principles from Eng's book. He calls them need-to-knows. Essentially, they're like the guiding principles for anyone who wants to use machine learning successfully.
And these principles are relevant whether you're a data scientist building the models or a business leader making decisions about AI.
Exactly. It's all about having a solid understanding of the fundamentals.
For sure.
So let's unpack these need-to-knows one by one. The first one is the importance of rapid iteration. What's that all about, and why is it so crucial in ML?
Well, remember that house selling analogy we talked about earlier?
Yeah, definitely.
So rapid iteration in ML is all about taking that experimental approach. Build something quickly, test it, learn from the results, and then make changes based on what you find. Keep going like that, iterating and refining as you go.
So instead of spending like ages trying to create the perfect model up front, you're constantly testing and improving your models, but in smaller, faster cycles.
You got it. And that approach has some big advantages. For one, you get feedback really fast, so you can spot problems early on.
Makes sense.
Plus, it creates this culture of experimentation and continuous learning, which is super important in a field like machine learning.
Okay, I can see how that would lead to quicker results and a more agile development process.
Oh, yes.
But for the data engineers out there, how do they actually pull off this rapid iteration in practice? Building, testing, and refining complex ML models all the time, that's got to be tough,
Oh,
right?
absolutely. It's not a walk in the park. That's where you need the right tools and technologies, the ones specifically designed for managing machine learning workflows.
Okay, so for our listeners who are into the technical side of things, we're talking about tools like Apache Airflow, Luigi, Prefect. They help automate and manage those complicated data pipelines.
Yeah, they're like project managers for your machine learning projects, keeping everything running smoothly and efficiently, scheduling tasks, managing dependencies, that kind of thing.
And then there are tools like Great Expectations for data testing and CI/CD pipelines, which automate code changes, all designed to streamline the whole ML workflow and make rapid iteration actually doable.
It's like having a well-oiled machine where all the parts work together perfectly to get those ML models out there faster.
Love that analogy. So rapid iteration is all about being experimental and using the right tools to make your workflow super smooth.
Exactly.
Got it. But what about the data itself? How can you make sure your models are trained on data that actually reflects the real world? Which brings us to our second need to know: proper data distribution and splitting.
Oh, this is a big one, and so many people overlook it. If your training data isn't a good representation of what your model will encounter in the real world, you're basically setting yourself up for failure.
Right, like you're training your model in a fantasy land, and then it gets thrown into the real world and has no idea what to do.
Exactly. Imagine you're training a model to recognize different types of fruit, right?
Okay, I'm following.
But if all your training data only has perfect, flawless apples, your model might not know what to do with a bruised apple or a banana that's not quite ripe yet.
That's a really good point. It shows why proper data distribution and splitting is so crucial. So how do data scientists make sure their training data is truly representative?
There are a few key techniques they use. One is called deterministic data splitting. Basically, it's about making sure you're dividing your data into training and testing sets in a way that avoids bias.
So you're not accidentally introducing any weird patterns or skewing things by just randomly shuffling the data.
Right. Another technique is distribution matching. This is where you make sure your training and testing data have similar statistical properties, so your model can generalize better to new data.
It's like making sure your taste testers for a new cookie recipe have different palettes.
Uh-huh. Perfect analogy.
You wouldn't want all your taste testers to be chocolate lovers if you're trying to make a cookie everyone will like.
Exactly. And that actually brings us to another important concept: data drift.
Data drift? What in the world is that?
Well, think of it like this. People's tastes change over time, right?
Sure.
Same thing happens with the data your model has to deal with in the real world. Let's say you've trained a model to predict what customers will buy based on past data.
Okay, I'm with you.
But then something huge happens, like a global pandemic. And suddenly, people's buying habits go totally haywire. Your model, trained on pre-pandemic data, is going to be totally lost.
Wow, yeah, that makes total sense. So data drift is basically when the real world data starts changing in a way your model wasn't prepared for.
You got it. And that's why you have to keep an eye out for data drift and retrain your models regularly.
So they can keep up with the times.
Exactly.
Okay, so far we've covered rapid iteration and proper data distribution and splitting. Now let's move on to our third need to know:
What's next?
single number evaluation metrics. And I'll be honest, this one doesn't sound quite as exciting. What's the big deal about these metrics?
I know they might not sound glamorous, but they're super important. Think of them like a scorecard for your ML model. They give you a clear, objective way to tell how well your model is doing.
So instead of just going with your gut feeling, you have hard numbers.
Right. And that's crucial for comparing different models and seeing how things improve over time. Let's say you're building a model to predict, I don't know, customer churn.
Okay.
You might have two different models, one using logistic regression and one using deep learning. How do you know which one's better?
Good question.
That's where the single number evaluation metric steps in. It gives you a fair way to compare those two models head to head.
Got it. Makes sense.
You might choose a metric like accuracy, which tells you how many of your predictions are right. Or you might use something like precision, which looks at how many of your positive predictions are actually correct.
Okay, but with all these different metrics out there, how do you pick the right one?
Another great question. It depends on the specific problem you're trying to solve and what you're really trying to achieve. Sometimes you even need to use a combination of metrics to get a complete picture.
So it's not just pick a metric and you're done. There's a real science to it. And I bet data engineers have a lot to do with designing these evaluation systems.
Oh, for sure. They need to make sure they're collecting the right data, defining the right metrics, and setting up robust monitoring systems to track how the model is performing over time. They might even need to build infrastructure for A/B testing.
A/B testing, now that rings a bell. Remind me what that is again.
It's basically running a controlled experiment. You show different groups of users, different versions of your model, then you see how they react to each version. Helps you figure out which version works best.
Oh, yeah, that's a great way to optimize things.
It's like having a constant feedback loop that helps you keep making your models better and better.
I love that. Okay, so far we've tackled rapid iteration, proper data distribution and splitting, and the importance of single number evaluation metrics. On to the next one.
Hit me with it.
All right, our fourth need to know is error analysis. Sounds like we're about to get into the weeds here, figuring out where our models are messing up.
You got it. No ML model is perfect, and error analysis is all about finding and understanding those errors so you can make your model more accurate and reliable.
Kind of like debugging code.
Exactly. You have to find the bugs and fix them. But debugging ML models is even trickier than debugging regular code. You're not just looking for typos or logic errors. You're trying to understand why your model is making certain predictions and how to make it smarter.
So it's not just about fixing the mistakes, it's about learning from them.
Right, and that's why you often need a team effort with data scientists, domain experts, and even end users all working together.
Kind of like a detective investigation.
Uh-huh, I like that.
You're gathering clues from all these different sources to figure out why your model is tripping up.
Perfect analogy. And just like detectives have their tools, data scientists have a whole toolkit for error analysis.
All right, so for our tech-savvy listeners, what are some examples of those tools?
Well, you've got interactive dashboards for visualizing errors, logging systems to track predictions and errors, and even feedback interfaces where experts can weigh in and share their insights.
So it's all about using those tools to understand the patterns in your errors, see if there are any biases, and figure out where your model needs improvement.
Exactly. By tackling those errors, you're not just making your model more accurate, you're making it more reliable and trustworthy.
Fantastic. So we've covered 4 of Andrew Ng's need-to-knows for successful ML projects: rapid iteration, proper data distribution and splitting, single number evaluation metrics, and error analysis. Now let's dive into the 5th and final principle: flexibility in learning approaches. What does that mean exactly?
Flexibility in learning approaches is all about recognizing that there's no one-size-fits-all in machine learning. Different problems call for different approaches, and you have to be able to adapt your strategy based on the challenge you're facing.
So it's like having a toolbox filled with different tools. Sometimes you need a hammer, sometimes you need a screwdriver, and sometimes you need a specialized gadget for a specific job.
Perfect analogy. And a skilled data scientist, just like a skilled craftsperson, knows which tool is the best for the job. They need to be familiar with lots of different machine learning approaches and be able to pick the most effective one.
Makes sense. But with so many different algorithms and techniques out there, how do you even begin to choose the right approach?
It's a mix of understanding the theory behind different approaches, having experience actually using them in real-world projects, and weighing the pros and cons.
Pros and cons. Can you elaborate on that?
Sure. Different approaches have different strengths and weaknesses. Some might be super accurate but take forever to run. Others might be easier to understand but less accurate.
So you have to figure out what's most important for your specific application.
Yep, and that's where understanding the problem you're trying to solve and the needs of your project comes in.
And I imagine data engineers play a big role in enabling this flexibility in learning approaches.
Absolutely. They need to build data pipelines that can handle different approaches so data scientists can easily experiment and try different things.
It's like building a system with interchangeable parts, so you can swap things in and out and try different combinations.
Exactly. That flexibility is key to innovation in machine learning.
Awesome. So we've covered all 5 of Andrew Ng's need-to-knows for successful ML projects: rapid iteration, proper data distribution and splitting, single number evaluation metrics, error analysis, and flexibility in learning approaches. Phew. That was a lot to take in, but I think we did a pretty good job breaking it all down.
I think so too.
Before we move on, let's just take a quick breather and recap those key principles one last time.
Sounds good to me. So just to recap, those 5 key principles are rapid iteration, proper data distribution and splitting, single number evaluation metrics, error analysis, and flexibility in learning approaches. Those 5 are really the foundation for building great ML systems.
Yeah, it's like having a roadmap for navigating the whole ML world. And what's really neat is that these principles, they're not just for data scientists or engineers.
Right, they're for anyone who wants to understand machine learning and how to use it the right way.
Totally. Whether you're a business leader, a product manager, or just someone who's curious about AI, knowing these principles can give you a real advantage.
It's about being informed and being able to really think critically about this technology that's changing so fast.
So if we were going to explain these principles to someone who's brand new to ML, what would be like the main takeaway, the one thing they should remember?
I'd say the biggest thing is that machine learning, it's a process. It's not about getting everything perfect on the first try. It's about trying things out, learning, and making things better as you go. And those 5 principles we talked about, they're your guide for doing that
I
effectively.
like that. Embrace the journey, right?
Exactly.
Now, the article we're looking at, it mentions something called the Data Innovators Exchange. What is that, and how does it tie into what we've been talking about?
The Data Innovators Exchange. Oh, it's a fantastic platform for anyone who loves data science and machine learning. It's a place where data professionals, researchers, even just enthusiasts, they can all connect and share ideas. They can even work together on projects.
So it's like a virtual community for ML folks.
That's a great way to put it. And I think it really reflects how important collaboration and sharing knowledge is in AI. We're all in this together, learning and growing, and platforms like this help us move faster.
It's like having a global network of mentors and colleagues right at your fingertips.
Exactly. And it shows how AI is not just about the technical stuff, it's also about human connection and working together.
That's a really good point. We've talked a lot about the technical side of things, but at the end of the day, machine learning is a tool made by people for people.
Right.
And if we want to use it well, we have to be open to talking to each other, working together, and thinking about the ethics of it all.
I agree completely.
Mhm.
The future of AI, it depends not just on how smart we are, but also on how well we work together, share what we know, and make sure this technology is used for good.
Couldn't have said it better myself. So if you're feeling inspired to learn more about ML or connect with other people who are passionate about it, definitely check out the Data Innovators Exchange. And of course, if you want to dive deep into Andrew Meng's wisdom, his book, Machine Learning Yearning, is the way to go.
It's packed with great advice and real-world examples that can help you take your ML skills to the next level, whether you're a pro or just starting out.
And on that note, we've come to the end of our deep dive into machine learning best practices. We hope you've enjoyed it and learned a thing or two about what makes for a successful ML project. But before we wrap up completely, I have one last thought I want to leave you with.
Oh, do go.
We've talked about iteration, data quality, evaluation metrics, error analysis, and being flexible in your approach. But what about the human side of things? Where does that fit in? As machine learning gets, more powerful and more woven into our lives, we really have to think about the ethics of it all, make sure these systems are actually aligned with human values.
Absolutely. Yeah. It's not enough to just focus on the technical side of machine learning. We need to think about the impact it has on society, potential biases, and all the ethical questions that come up when you're building and using these systems.
Because ultimately, these systems are making decisions, right? Decisions that affect real people. And those decisions need to be fair, unbiased, and we need to be able to explain them.
Exactly. And that means changing how we think about these systems, not just for data scientists and engineers, but for everyone involved. We have to see them as more than just tools. They're like extensions of our own intelligence, and we need to treat them with responsibility and ethical awareness.
It's like, think about how social media algorithms have shaped our society. It's clear these technologies can have huge consequences. And as machine learning gets even more advanced, we have to be really thoughtful about how we develop it, make sure it's benefiting humanity, not harming it.
I couldn't agree more. And these conversations about AI, they need to involve people from all walks of life. Ethicists, social scientists, policymakers, and tech experts all need to work together to create a framework for responsible AI.
So it's not just about the code itself, it's about the values that code reflects and what impact those values have on the world.
Precisely. That's why it's so important for everyone to have at least a basic understanding of how machine learning works and what the potential consequences might be.
Because at the end of the day, AI is a tool, right? And any tool can be used for good or bad. It's up to us to make sure it's used to make the world a better place.
That's a great way to put it. The future of AI isn't set in stone. We're shaping it right now with every decision we make.
So, to all our listeners out there, as you keep exploring this amazing world of machine learning, remember to think about the ethics involved. Because the future of AI isn't just about data and algorithms, it's about people and the kind of future we want to build together.
And as we wrap up this deep dive, remember that learning never ends. There's always more to discover, more to explore, and more to talk about. So stay curious, stay engaged, and keep those minds active.
And until next time, happy learning.